So here's the outline for lecture 2. Last time we very briefly introduced Python language. We looked at some introductory details. Now this is the time to go into some further details that we will begin with the essential things that we need to know about Python programming. So the outline says basic Python data types and objects. That's the first thing we will look at. And the immutability or mutable and immutable objects. After that, we have to be able to do input-output in order to do even to see a simple program working. So we look into that. Later on, file read and write. Expressions and operators comes after that. And finally, Python keywords and built-ins. So this is basically the content for today or this lecture. And so this, as always, we tell you what the lecture, in the lecture notes, what are the sections that we cover or that is related to this lecture. So for this particular lecture, lecture number 2, what is relevant in the lecture notes part A is chapters 2 and 3. And you can see the same content in the corresponding Jupyter notebooks as well. The special thing about Jupyter notebooks is that you can see the code examples running. So you may not see that much things there in the chapters 2 and 3. Simple examples are there, but you will see the usefulness of Jupyter notebooks later on when you have more complex programs and examples, right? Without having to type it again in a Python editor or running it separately on Python, we can just run it in the Jupyter notebooks itself, right? In addition, we provide these, as always, we provided these details, references last time as well. The standard documentation for Python tutorials and documentation will always be helpful if you want to refer, right? And also we have this the Python to visualize Python execution, the pythontutor.com site, which we introduced last time. Right, these are basically additional things. Actually, we expect you to read through the notes, the relevant parts, the chapters 2 and 3, as a part of this exercise. So either before this or after this, either way it's fine, because that will contain some detailed descriptions also, which you will find useful in addition to this lecture slides and the videos. All right, let's go forward. Right, so this lecture, as usual, will be divided into several parts. So let's start part 1 by looking at the basic Python data types and objects. Let's proceed. Right, so here are the basic Python data types. So what do you mean by data type? So in any programming language, right, any high-level programming language, you will see that we develop programs to solve computational problems. And what are the data that we need to handle? Right, so the data comes in, either data can be numbers or data can be letters, characters, and various things, right? Of course, there can be very complex kinds of data. You can imagine, let's say, if you take a photo of a certain person, a digital image is maybe another type of data. A particular program you may want to develop a program to do something about an image, or maybe a video or an audio, things like that are there. But let's get started with the basic, the simplest forms of data. And any language, programming language, have certain kinds of data that they support. And as programmers, we have to know them in order to use the program, the language effectively, right? And of course, when you talk about the lowest level at the hardware level, yes, there are data types that, for example, numbers can be of different types. We call integers and floating points, or integers and real numbers are differentiated at the hardware level also. And so at the high level in the programming language, we can see various, we call them data types. So with Python, we have these numbers. Numbers are we call numeric types, right? So numeric types means basically numbers. So what type of numbers can you represent in Python? One is the whole numbers, which are called integers. Integers have a shortened name within Python, so that's basically called int, right? And the next you have floating point numbers. That is, the floating point is the term used in computing to refer to real numbers. So what's a real number? Real numbers are the ones which have fractions part of it. These are not integers, basically, right? Real numbers are referred to as floating point numbers. We'll explain it later on. We will have a separate discussion on data representation in computers. There we will look at some more details about integers as well as floating point numbers, how they are represented inside computers. But for now, just you can go with this. You simply accept what we describe here, that real numbers are referred to as floating point numbers. Okay. And within Python, the short name for those is just say float, right? In the various other programming languages also, we have the similar names. In C and Java, for example, you can see int and floats are there, right? And Python has a special another numeric data type for complex numbers. So it's a built-in type. So Python supports complex numbers as a basic data type, and they are referred to as complex, right? And so that's basically the main numeric data, three numeric types for numbers. So for different purposes, so if your computation is purely on integers, you can just work with integers. But if you have to deal with real numbers, then the floating point numbers will be basically relevant, right? And if you want to use complex numbers, again, you can use complex numbers, right? You don't have to basically, in another programming language where complex numbers are not supported, if you have to deal with complex numbers, then as a programmer, it will have to deal with it. It will have to find a way to represent complex numbers and then use it accordingly. But here in Python, you have complex numbers, right? And then we have a Boolean type called bool. It can be considered as some type of int. Basically, they have two values, right? True or false, right? Either true or false. And so those are basically some of the basic things. What else? Right, one more type. This is string type. str is the shortened form. Now, this is also somewhat special in the Python language, because in a language like C, you would have characters as a basic type, character, a single character. Then you can have a sequence of characters together, which we can refer to as a string. But string is simply a data structure that consists of multiple characters in a language like C. Whereas in Python, it's basically a string. Any string is basically a basic data type. And as a special case, you can have a single character, which is also a string, right? Any single character is by itself a string. So there's no distinction here. So a string is a string, even a single character is a string. All right. So these are the basic types. And for most of your programs in the early part of the semester, maybe until about, let's say, initial few labs, for example, programming labs, you will be dealing only with these things. Perhaps occasionally, lab number, when it comes to programming lab 5 or 6, you will have lists coming in. But most of the things you will be working with just these data types, right? We will actually cover some other data types, or we can call them compound or composite data types that are supported by Python. We will discuss them later on. For example, there are lists, tuples, dictionaries, sets, and so forth. There are several. We will, I think, use lists quite a lot later on. And of course, you can use tuples also and dictionaries. But in most of the semester one CS1033 work, the most common data type would be the composite or the compound data type would be lists, I believe. So, so what is just to give you an idea, a list is basically a consist of various other maybe several data from basic data types, and even a list can be a list of lists also, right? So a list can contain any of other things, right? So it's basically a collection of various data, types, right? And so those are having now introduced these things. So let's move forward. Yeah, so the compound or the composite data types, for example, lists, tuples, and so forth, can be considered as basic data structures that are provided by Python, right, as like built-in. So they're available for us to use. But if you want to do more complex things, programmers can always create new data structures, right? Any programming language, any reasonable modern programming language must and will support creation of new data structures if you want, right? So that's an additional thing. But here we have some basic data structures that are provided by Python that are available for us to use without having to create. I mean, this will serve multiple purposes. They can be useful for in many situations, right? All right, then let's move forward. Let's take a few examples. Situations here as examples. I am actually showing you some interactive session on Python shell or Python interpreter. So you can see these the three greater than sign symbols indicate that I am working with a Python shell. And so if I can give this statement, so this is a valid Python statement. It says A equals string ABC. So double quotation is one way to indicate a string, and say plus and XYZ, another string, which is a single quotation. So in Python, you can represent strings in either within double quotation marks or single quotation. Either way, it's fine. And when I say A equals ABC string plus XYZ string, does it make sense? What is plus? Okay, yes, actually, if I give a Python statement like this and hit enter, if there was an error, it will complain, but there was no error here, so it accepted it, right? And when I type A again, it will give the value of A. Now, A, we will learn later today, that is referred to as a variable, it refers to what we call a string object. Now, this string object basically has this value. So A has this value. We can say A refers to string object that has value A, B, C, X, Y, Z. So how did we get this string together? From this operation, right? So plus, if you do a plus operation between two strings, they are merged together, right? They are merged, which we use another term for that called concatenation, or we join two strings together using plus symbol, right? And in Python, you can do this kind of thing very easily. Now, this kind of thing is not supported directly in other languages like C language. Now, you remember in lecture 1 also we used C language. We explained to you why we referred to C language, just to make some comparison for you to understand Python things a little better, right, in the context of various programming languages. So here also, from not only here, I mean, from time to time in various situations, we will try to explain things by contrasting Python with another language, so that again, for you to have a better understanding, right? To have a complete understanding, even differentiating something with Python and another language will be helpful. And just I want to say to indicate the convenience, the easiness of programming with Python. One example is this. You can simply join strings using a plus symbol, which you cannot do with C. You have to write significantly more amount of code to achieve that kind of thing, right? And so if you just say A, it will give its value. And when it is displaying a string, it will display with a single quotation, right? That's what you see here. So in black color, in these interactive sessions, you will see the statement that or expression that I type at the shell prompt or the Python shell. And in this, after that, in red color, I show the response from the Python interpreter. Right. So I type. So then next I go and type this thing, type type within parenthesis A. Now type is a built-in function. We call it a function, a Python function. And inside that, we have to put an argument. Basically, we have said A here. The idea is that we are asking Python to tell us what type this A is. And it tells us that it is a class string. So class is another name to refer to types. So in Python, we refer to string as a data type, but it can also refer to as a class. So it is a built-in class. So when you want to know the type or a class of a particular data value or a data element, you have to simply use type function, and inside that you give that as an argument. Right? We say A, we call it argument. We are calling a function type, and A is the argument. And it will check what A is, and interpreter tells us it is a class string. Right? That's what we see here. And let's say we say B equals 97. Now, 97 is an integer we know, right? And if I ask using the type function again, what the data type of B, it will tell that it is class integer or int, right? Int is the short name. So this is basically what we expected. According to what we explained earlier, as a basic data type, right? Integer is a some 97 is a integer value. And I will basically say, okay, if you want to have another thing, so you can even give the as argument the data itself here. So 97.0, if I include as argument here for the type function call, you get value. The result response as class float, because 97.0, of course, 97 is 97. You can say this 97 and this 97 have equal value, but actually there's a difference when it comes in Python. The moment you put decimal point, whether with another digit after that or not, the moment you have a decimal point within a number, it is considered a float number. Right? Without that, it is an integer. Okay. So continuing, so here's another example. We say D equals 5 greater than 4, and there's no complaint about it. So when I say D, it gives the value of D as true. Why is that? Because D, 5 greater than 4 is a true, and the value of D is true because the type of D is what? It is bool, a Boolean type. So that's also, I think we explained earlier, bool is a basic data type. And here is an example where you have a Boolean value, true value here, because 5 greater than 4 is true, right? And here's another example, E equals 3 plus 4J. What is that? So let's check. So it didn't complain, it accepted. So when I say type E, it tells that it is a complex number. So this is how you represent complex numbers in Python. So this is the real part, and this is the imaginary part. And in the normal mathematics, we would have used I to indicate the square root of -1. But in Python syntax, J is the equivalent of I in complex numbers. So J indicates square root of -1. And it is represented after the number, after the imaginary part. So not like in the case of a real complex number, in normal mathematics, you will write this as like this, 3 plus I4, right? So this is basically 3 is the real part, 4 is the imaginary part. I indicate the square root of -1, right? Like this. Now, in Python form, and as square root of -1 is actually J, and it is comes after the imaginary part is removed, right? In this case, the 4 is the value of the imaginary part, right? That's how complex numbers are represented. All right, right. So let's basically Okay, so let's go forward. Now here are some examples, data types like int and float, and just wanted to show you different ways that integers and floating point numbers can be represented. A few examples. Now, the first one, so if you say minus 96, it's basically an integer value. It's a negative integer. This is one way of representing in the decimal normal format, right? That's we are familiar with. But we also can use other representations like hexadecimal, octal, binary. These we will look at what this hexadecimal, octal, binary in a separate discussion called data representation later. But for now, it's basically hexadecimal is with base 16. Any base 16 number in Python can be represented using 0 followed by X. So this indicates that it is hexadecimal. And after that, this is actually the number. So the number is actually 3BFE9. And the 0 and X before that tells that this is a floating point number. Similarly, octal, in the case of octal numbers, 0 followed by O. This tells that it is octal number. The number itself is 3702. This is the number. And in this case, this is actually a minus, because you can see a minus sign or negative sign there. That indicates this is a negative octal number, right? And then finally, we here show how we represent binary numbers within Python. 0 followed by B. And this indicates that the remainder will be a binary number. This 100101, this part is the actual number, right? So these are some examples. Floating point examples, say 9.01 and minus 9 dot, even with single dot here without anything after that, itself is a floating point number. So just minus 9. And here is a way to represent 32.3, and E indicates 10 to the power. So this is actually equal to 32.3 multiplied by 10 to the power 18, right? And this one is a negative number, minus 321.54 multiplied into 10 to the power 100. But this is into 10 to the power. Oh, sorry. So let me write it again. So this is minus 321.54 into 10 to the power 100, right? And then the last one, again, I think we can understand that it's 8,734.098 into 10 to the power minus 12. The differences are that you can see a plus or minus value can be there. It's optional. For this one, it doesn't make a difference. It's 18 is 18. But you can see here minus 12. It's indicate minus 12. The power is minus 12, right? Right. So basically, that's some different ways that you can represent data within your programs as Python understands these things. In your Python expressions, Python statements, you can include these and type these things in this way, right? Right. Let's move forward. Okay. So we have some idea about some examples we have seen. Now let's look at objects. Objects are basically data items, say, right? We say objects are Python's abstraction for data. It's basically, that means data in a program are represented by objects or even as relations between objects. So another way to understand is simply data items, right? Data instance, if you have a number 5, integer number 5, so we can say 5 is an integer object and whose value is 5, right? And if you can have a string, let's say string, the contents of the string is, let's say, Morotua, and we can say, oh, there is a string object whose value is Morotua, right? So like that, it's some examples. So objects are the Python's abstraction for data, how you represent data in our programs. And objects have certain interesting properties. So let's list them. Every object has an identity, which is actually how it is represented in the computer location. It indicates its location. Basically, I mean, it may not exactly, I mean, you will learn, I think you may have some idea about how computers work. There's something called a memory. So that is where the data are stored for processing. So there is a processor and there is memory. And processor is processing this data by bringing in that data from the memory into its processor, into its registers, and process does something about it, and then results are sent back, written back to the memory. So the identity here can be understood as an address in memory. It may not exactly, if you go into the most accurate details, it may be something related to the address. But for our purposes, you can consider that as an address in memory. And this will never change. So if you have an object, its value may change, but its address or the identity will never change because it just simply sits there, right? Is located in that place. That's where we can understand. If you want to know the identity, you can use it. You can get it using the ID built-in function call of Python. You can also use identity for comparison purpose using IS or is operator, which we will explain later. And another thing every object has is a type or a class. We have already seen this, right? You can check the type of any object using the type function, right? And what kind of operations you can do, right? Possible operations and what kind of values data object can have, these depend on the data type, right? So obviously, an integer data type can have integer values. It cannot have floating point values, right? Things like that, okay? And then, obviously, every object has a value, right? For example, if I have an integer 5, value being 5, so we can say, okay, that's integer object whose value is 5. As a string object whose value is monotool, right? A string. Or another string with a single letter, let's say X, right? So that's also a string object with value being X. So objects have value has a value. So these three are important things to remember what every object has, right? And value of some objects can change, whereas some other objects cannot change, right? So we will basically talk about it a little later. So let's proceed with this. Objects can have names, right? We can associate a name with an object. That's what we do in our programs. We have data, but we want to refer to this data. So what do we do? We give a name, right? We refer to an object by its name. So we can associate the name with an object. In fact, a particular object can have no name at all also. Or it can have one name, or it can have many names, right? That's what this says. An object may have 0, 1, or more names, right? As you will understand, I'll show you a couple of examples later. There are other terms that are used to refer or reference identifier or variable. They also mean the name. So sometimes we just say a variable or reference, right? And when you name objects, here are the variable naming rules. You have to always start with the letter. That means lowercase letter or uppercase letter. Or you can use the underscore character also to begin the name of a variable. Then after that, you can have letters, digits, or underscore only. You cannot have other symbols like plus symbol, star, things like that. You cannot have inside a variable name. Okay. And variable names are case sensitive. So if you have a variable name like it's total and total, so these are two different things. Because here there's a difference, right? So case sensitive means that capital, simple, or uppercase, lowercase difference is there. Okay. Right. Let's move forward. Yeah, one other thing is now any programming language have a set of keywords or reserved words. Those have special meaning. Obviously, you cannot use them as variable names. So I will show you later what keywords we have in Python. And if you look at when you read the lecture notes, also you'll see a list of reserved words being there. Right. All right. So with that, we come to the end of part 1.